Okay guys, today we're going to talk about ellipse applications on page 20 of your notes packet. Okay, so ellipse applications, there are a few places where ellipses turn up. One of them is a lot in astronomy when we talk about planets' orbits, and that's exactly what our example's about here. Okay, so talking about Kepler's laws, we have planets in elliptical orbits, and the sun ends up at one of the foci. The farthest Pluto gets is about 7.4 billion kilometers from the sun, and it gets as close as 4.4 billion on the other end. We want to find the length of the major axis, and then find the distance between the two foci, and find the equation for the orbit of Pluto. Now, I'm going to start by drawing a picture with everything that we know here. So we'll start with a pretty straightforward ellipse, and I'm going to use a horizontal one just because it seems like it'll be the simplest way to draw this. Is my ellipse, and let's start adding some details to this. So the first thing is I've got the sun right here at one of my foci. Okay, and what we know is this is Pluto's orbit, and the distance when we're at our closest point, so from this foci to this vertex, is going to be 4.4 billion kilometers. And I'm just going to use the numbers, and we'll just always keep track that it's billion kilometers. Okay. On the other side, we know that the farthest distance that you get is going to end up being 7.4 billion kilometers. So this is 7.4. And on the other side, we know there's also going to be a foci over here, okay, but specifically not necessarily the sun. Now, some things that we can assume, this blue line right here should also match up with this line right here. So we can say, hey, that's got to be 4.4. And if the whole red area is going to be 7.4, we can figure out that section in the middle by subtracting. So we can do 7.4 minus 4.4 to get that this center area is going to be 3. So from this foci to this foci, we can say this line right here is going to end up being 3. Okay. And in total, that whole red section was 7.4. Okay. So we've actually figured out one of the answers already, and that is the distance between the two foci, right? So the distance between the two foci is going to end up being 3. All right. So with that information, let's go ahead and also try to figure out the length of the major axis, right? So major axis is, of course, from vertex to vertex. And if we just add up the 3 measurements that we know, we should be able to come up with that. So if we did 4.4 plus 3 plus 4.4, we would end up with 11.8, and that will be the major axis. Okay, so remember these are all billions of kilometers. So 3 billion kilometers is the distance between the two foci, and 11.8 billion kilometers is going to be the length of that major axis. So from closest to the sun to farthest from the sun. Okay, and now the next thing they ask us is, hey, can we figure out the equation of the orbit of Pluto? Okay, and we absolutely can. So what we'll do is we of course want to figure out A and B in order to be able to fill this in. And the easiest point is probably to just put, hey, this center, we'll just call it 0, 0. And that kind of just simplifies the equation. So we just have x squared over a squared plus y squared over b squared equals 1. Okay, and of course we just need to figure out what a and b are, and we'll be good to go with this parabola. Okay, so remember guys, a squared, well, a is just the center to the vertex, right? So if we were doing that, it is just half of the major axis. Okay, so 1/2 of this major axis is A. Okay, so we can do that math, 1/2 times 11.8, and we should get that A is equal to 5.9. Now, B is a little bit trickier, all right, because we don't really have a measurement for it yet, and I have no idea how wide my ellipse is, okay? So what we're gonna end up doing is we're gonna rely on the formula that connects the major and minor axes together, okay? And it goes as a squared minus b squared equals c squared, okay? So this is the relationship between the two axes, right? Major axis versus minor axis. So let's go ahead and find C, okay? And remember, C is the distance from the center to the foci. So I'll just do it in another color here. So if we change colors, you'll see C is going to go from that midpoint to the foci, and it is half of the green line, which means this is just 1.5. Okay, so we know that C is going to end up being 1.5. And let's use this relationship to help us solve for B. So here we go, we're going to find B. So 5.9 squared minus B squared equals 1.5 squared. We can rearrange this. 5.9 squared minus 1.5 squared is B squared. And we can take this and plug it in our calculator, and we should get that this is 32.56 equals b squared. And of course, we do really want to solve for b individually, so we'll just take the square root of each side. And we've got 5.706 as our b value. Okay, so now that we've got these two, we've got a and we've got b, we can just kind of fill in the equation and we'll simplify everything at the end. So right now, with the a and b values that I know, we've got x squared over 5.9 squared plus y squared over 5.706 squared equals to 1. And we can kind of tidy these numbers up a little bit, and we should kind of get a nicer equation that looks like this. X squared over 34.81 plus y squared over 32.56 equals to 1. And this is going to be the equation for Pluto's orbit. And we've, of course, actually answered all three questions from this problem. So first, the length of the major axis, we got that to be 11.8, kind of the total of these distances across from here, okay? And the distance between the two foci, we got that to be 3 when we subtracted. And then, of course, we finally got that equation for the orbit of Pluto. Okay, guys, let's try another example. Looking at number 2, talking about a hallway that's designed to be a whispering gallery. So, fun fact, guys, if you don't know what a whispering gallery is, it's basically an area that's designed that if you stand in that gallery, basically, even if you were to whisper, that sound would still carry all over it. And these are always usually elliptical or like semi-sphere kind of shapes so that we can get that effect. All right, so let's see what this ellipse is all about. First thing, of course, we should start with our picture. So here is going to be my ellipse, okay? And the first thing they mention is that the hall is 100 feet in length. So there, my major axis is going to be 100 feet. Okay, so let's just make some notes here as we go. My major axis is 100 feet, which means, of course, the distance from the center to one of my vertices, right, is going to be A, which is going to be 50, because it's exactly half of this, right? And of course, there are two locations that are foci or focuses for my ellipse, one on either side of that center. Okay, just a little basic stuff about the ellipse. Right, so the focus is located 25 feet from the center. So each of these distances right here is 25 feet. Okay, and so basically we know that from the center to the focus is 25 feet, which is actually letter C. Okay, so these are from center to focus. All right, and basically now, guys, we actually have everything we could want for this. We're just going to solve for B, which is, of course, the height that we're looking at. So what we'll do is let's just go ahead and set up our equation. C squared equals A squared minus B squared. We'll just plug in with the numbers that we know and start solving away. So we've got 25 squared is 50 squared is B squared. We can rearrange this a little bit. B squared is 50 squared minus 25 squared. And we should get B squared is around 1875. And of course, we can take the square root of this to get our approximate value for B. And that should be 43, give or take 43.301. Okay, and that is of course my height in feet for this. Okay, so I didn't even have to write the equation for this one. What I did was we took everything that we knew and kind of put it on the picture and then just solved for this B value. Okay, so the critical pieces here, we're realizing that our major axis is of course 2a. All right, we use that to help us solve for B, right? So this was 2a. And we got C, which is the distance from the center to the focus. Solve for B using our formula, and that was our answer in this case. Just to kind of make sure that we have everything locked down, we could go ahead and write the equation for this ellipse, and remember the basic form, x squared over a squared plus y squared over b squared equals 1. And again, this is the horizontal form, right? Y over a squared would have been if we were vertical. So now just plug in our numbers, x squared over 50 squared plus y squared over, that's our 43.301 squared. And basically we know we're going to end up with x squared over 2500 plus y squared over 1875 equals to 1. All right, so that's actually our equation for the whispering gallery, but it didn't really ask us for that, but we can very easily find it just plugging in our A and B values into that. Okay, hope this video was helpful. Good luck and happy studying.